All right, we're going to take a look at how to factor this quadratic, thinking about the algebra tiles, but we're just going to model them with the generic rectangle. If you notice the a term, those x squareds, and the unit tiles, they've always been diagonal from each other. So we're going to put those diagonal from each other in the generic rectangle. And now these x's, they're going to get separated in these two boxes. But we don't know how to break them up. We could guess and check, but that's going to take a while. So instead, let's use what we learned yesterday about the diagonals. We learned that the diagonals, when you multiply them, they're equal. So if I multiply this diagonal, I know that the other diagonal, these two numbers have to multiply to give me 8x squared. I also know that they're going to add to give me 9x, or the b term. So I remember with the b term, b, so we have ax squared plus bx plus c. So that b term is going to go in the bottom of the diamond. So now we want to think of two numbers that are going to multiply to give us 18x squared and add to give us 9x. So we have 1 and 18, and 2 and 9. Which of those pairs is going to add? And we also have 3 and 6. Which of those pairs is going to add to give us 9x? 3x and 6x. So we can put those on either side of the diamond, doesn't matter. And then we can put them in either box of the rectangle because it would just rotate. It would still be the same rectangle regardless of where you put them. So now I want to find the greatest common factor of every column and every row. So I can start maybe up here, 3x and 18, that would be 3. This is an x squared, so that's going to be an x times x. So now I want to think, what times x is 6x? That would be 6. And then I always like to double check myself. 3 times 6, that's 18. So I have the quantity x plus 3 times the quantity x plus 6.